Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, let's start by looking at some questions for our formula for gravitational potential energy. So question number 1 is, what height has a man of mass 80 kilograms moved through if his decrease in gravitational potential energy is 160 joules? So, as always, we want to start with our equation. Gravitational potential energy is mass times g, which on Earth we need to know is 10, times h height. So, putting in the numbers from the question, we have 160, our GPE, equals mass 80 times g10 times h. So just to simplify that right-hand side, I get 160 equals 800 multiplied by h. And then if I divide through by that 800, I get my height to be 0.2 meters. And it asked if he has decreased his gravitational potential energy, did he move up and down? And you should know that as things get lower and lower and lower, they are decreasing their gravitational potential energy. So he moved downwards. Okay, question number 2. Calculate the increase of GPE of a pen of mass 50 grams that has moved up 3 meters. So again, let's start with our formula. GPE equals m times g times h. So plugging in our numbers, GPE equals, now that's 0.05. What I've done there is I've divided that 50 grams by 1,000. And hopefully by this point in the course, you're working out why I might have done that. And that is because my mass needs to be in kilograms instead of grams. Okay, multiply by G10, multiply by 3, my height, and that gives me 1.5 joules. Okay, and finally, how many meters would you raise an apple that has a weight of 1.5 newtons to increase its GPE by 5 joules? So again, let's start with my formula. GPE equals m times g times h. This time, I've been given the GPE 5, but I haven't been given the mass. I've been given the weight of this thing. So we need to remember that weight is actually the object's mass multiplied by g. So the weight of this apple is 1.5 newtons. Okay, so then I can plug that into my equation, because actually I have my GPE, which I put 5 on my left hand side, equals the weight, or m times g. So that's that part of my GPE equation, multiplied by height. Okay, and then dividing through by that weight, 5 divided by 1.5 is h, which is 3.3 meters. Great, moving on to our equation for kinetic energy. So our first question is, what is the kinetic energy of an average person walking? So let's start as always with my equation. Kinetic energy is half times mass times velocity squared. So now I need to decide what's the average mass of a person and what is roughly their velocity if they're walking. Average mass of your average man would be about 80 kilograms, and a good estimate for a speed for walking would be 1.5 meters per second. So I can just plug those into my equation. Half times 80 mass times 1.5 squared. Remember that squared, people often leave it out. And that is equal to 90 joules because it's in energy. Okay, question number 2. What is the speed of a vehicle of mass 3,000 kilograms going with a kinetic energy of 150,000 joules? So let's write out my equation. Half mv squared. And now that 150,000 joules is my KE. So that's equal to a half times the mass 3,000 multiplied by v squared. So let me simplify that right hand side a little bit. I've got 150,000 equals 1500 times v squared. Now I'm going to divide through by the 1500. So I get 150,000 divided by 1500 is v squared. So my v squared is 100 and my v is 10. And I would recommend doing it in that many steps in your exam to avoid making some mistakes when you're rearranging this formula. Okay, final question, a bit of a challenge one here. What is the mass of an object with a speed of 40 kilometers per hour and a kinetic energy of 200,000 joules? Okay, Ke is half mv squared. But the first thing I notice is that velocity in my question is not in meters per second, so I can't use it in the form that it's in. It's actually in kilometers per hour. So I need to work out how to change that into meters per second. And I'm going to do it in two steps. Okay, the first step I'm going to take is say, okay, 40 kilometers per hour, how many meters is that per hour? I know that there are 1,000 meters in 1 kilometer, so there must be 40,000 meters in 40 kilometers. Okay, so now I've got that into meters per hour. How do I get it into meters per second? Well, I think about the fact that there are 3,600 seconds in an hour. So if it's 40,000 meters per hour, I divide that number by 3,600. That gives me my velocity in meters per second, 11.1. Okay, good. So now to plug those numbers into my equation. So kinetic energy was 200,000 equals a half times mass times 11.1 squared. So I get, if I simplify that right hand side, I get 200,000 equals 61.7 multiplied by m. Therefore, dividing that 200,000 by 61.7, I get 3,241 kilograms for my mass. Okay, moving on to questions where I have to think about GPE and KE together. So we have a stone dropped. It has a mass of 5 kilograms and falls through a distance of 4 meters. What is the stone's final speed? So since this stone is dropping, what I can think about is the fact that its height is getting less and less and less and less and less. And so it's losing the gravitational potential energy, and that is being transferred into kinetic energy. So my approach to these styles of questions is to work out the total initial energy of the thing, so that's its gravitational potential energy, and then I can set that equal to the kinetic energy that it gains. So I want to work out GPE that it has lost, so that is its mass times G times H. 5 kilograms times 10 times that height of 4 gives me 200 joules of gravitational potential energy that this object has lost. So that 200 joules of GPE has been transferred to this object's kinetic energy. So now I need to introduce again my kinetic energy equation, half mv squared. So I've got 200, the Ke, equals half times mass 5 times velocity squared. So simplifying that, I have 80 is equal to v squared, and therefore if I square root that, I get 8.9 meters per second. Okay, now we're going to do an example where it's kind of the other way round. So this time you have a ball which is kicked up into the air at 5 meters per second, so it has some kinetic energy. It has a mass of 500 grams, and I want to know what is the maximum height that it reaches. So this time, the kinetic energy that the ball has, as it gets higher and higher and higher in the air, that energy is being transferred into gravitational potential energy, okay, until it reaches that maximum height, and that's where its kinetic energy is 0, because the ball will be just still, just at that point when it's at its maximum height. So again, I need to calculate the amount of kinetic energy that this ball has lost first. So K is half mv squared, half times mass is 0.5 because I need it in kilograms, not grams, times 5, its velocity squared, gives me 6.25 joules. So that tells me that this ball is going to have gained 6.25 joules of gravitational potential energy. So then if I set that 6.25 equal to mass times g times h, then I end up with 6.25 is 0.5 times 10 times h. 6.25 is 5 times h, and then dividing that 6.25 by 5, I get my height to be 1.25 meters. Okay, time for a slightly more involved question. So we have a parachutist of mass 80 kilograms moving at 10 meters per second. At this speed, that is when they are 3,500 meters above ground, and then they fall to 3,450 meters above the ground. And we want to know what their speed is going to be when they are at that new height of 3,450 meters above ground. So in this example, we have still got some gravitational potential energy as they fall being converted into kinetic energy. So my first step is still to work out how much gravitational potential energy do they lose during that fall. So mass times g times h, 80 times by 10g multiplied by, well, I need to work out the distance that they fell, and since they went from 3,500 to 3,450 meters, that difference that I'm going to get is going to be 50 meters. So I have 80 times 10 times 50 is 40,000 joules of gravitational potential energy. So that 40,000 joules that I've lost of gravitational potential energy is going to go into this object's kinetic energy. So I need to first work out what was this object's initial kinetic energy. So the initial kinetic energy of this object, unlike the previous examples, was not 0, but it was a half times mass, 80, times its speed squared, 10 squared, or 4,000 joules. So the final kinetic energy of this object is going to be that initial kinetic energy that it had, plus this extra kinetic energy that it has gained by dropping this height. So that is 40,000, that's the number I got for the change in GPE, plus 4,000, its initial kinetic energy, 44,000 joules, okay? So now I have got this parachutist's total kinetic energy at this new height of 3,450 meters. So I can set that equal to the equation, half mv squared, and so that is equal to half the mass is 80 times v squared, and if I divide that 44,000 by a half times 80, and then take the square root, I get that V is 33 meters per second. Okay, another slightly challenged question here. So we've got people of different masses go down a water slide. Show that the mass of the person going down the slide does not make a difference to their speed at the bottom of the slide. So we're talking in terms of energy transfers. So we have got their gravitational potential energy that they have at the top of the slide gets transferred into kinetic energy at the bottom of the slide, and ultimately I could then use that kinetic energy to figure out the speed of the person at the bottom of the slide. So in other words, we have mgh that they lose is going to be equal to half mv squared that they gain, okay, because their initial kinetic energy was 0. If I rearrange that question, so I take that left hand side and divide it by a half times m, that leaves me with v squared on the right hand side of my equation. So to get an expression for their velocity v, I first need to simplify that left hand side. So if I simplify it, the masses cancel, and that half, because it's on my denominator, gets moved up to the top. So I have 2 times g times h is v squared. And therefore v is root of that, root 2gh. G is 10 and h is just to do with the height of the slide, so I can see that that speed is independent of mass. This is quite an extension question. if you are uncomfortable with maths and algebra, don't worry. It's very unlikely that your GCSE would have something so algebraic. There'd usually be some numbers for you to plug in to have a go. Okay, now to look at some questions using our formula for work done. So, what is the work done by pulling a box with a force 6 kilonewtons, 40 centimeters? Let's get our equation. Work is force times distance. Okay, and my force should be in newtons. It's currently in kilonewtons, so I need 6,000 instead of 6 newtons, multiplied, and distance needs to be in meters. So 40 centimeters is 0.4 meters. 2,400 joules. Okay, question 2. What is the distance travelled by a car that has a braking force of 5,000 newtons whilst it comes to a stop, and the car initially has 100,000 joules of kinetic energy? So, work is force times distance, and the work that this braking force does on the car so that it can come to a stop is going to be equal to the initial kinetic energy of the car, okay, because I want all of that kinetic energy to be transferred into heat energy, and my work will tell me how much energy is transferred. So I can set work equal to kinetic energy because I know all of that kinetic energy has to go if this car comes to a stop. So 100,000 joules equals force, 5,000 times distance. And therefore my distance is 100,000 divided by 5,000 is 20. Just to be clear, on that previous example, that was 20 meters. Okay, what is the work done by gravity as a rock falls through a distance of 5 meters and the rock has a mass 2 kilograms? So again, let's write out my equation. Work is force times distance. And since this rock is falling under gravity, I might want to think about what force is acting on this rock. And that is, of course, the weight of my rock, which is its mass multiplied by gravitational field strength. So I can work out my force in this question by doing 2, the mass, multiplied by G10 is 20 newtons. And then to find the work, I multiply that by the distance. 20 times 5 is 100 joules. Okay, next question. What is the initial speed of a trolley that comes to a stop with a frictional force of 20 newtons over a distance of 100 meters, and the mass of the trolley is 50 kilograms? Okay, so like previously, I need to appreciate that all of that kinetic energy needs to be transferred into heat via this work done with this frictional force. So I can set my kinetic energy equal to my equation for work done. So let's figure out the work done first. My force, 20, multiplied by my distance, 100, gives me 2,000 joules. Set that equal to kinetic energy, half mv squared. Add my mass in there, so I've got 2,000 kinetic energy is half times 50 times v squared. Rearranging, my v squared is equal to 80 and v is 8.9. Okay, now to look at our equation for power. So question here, what is the work done by a device with the power of 3,000 watts over a 5-minute period? Let's get our equation. Power is energy over time. Okay, and I've used the expression work done in my question, but remember, work is just energy transferred, so work is energy. So I can plug in 3,000, my power, equals energy over time, but I need to make sure that time is in seconds. So that's why I've got that 5 minutes multiplied by 60. So we have 3,000 is energy over 300, which if I multiply by 300, I get my energy to be 900,000 joules. Okay, question number 2, what is the power of a computer that transfers 100,000 joules of energy in 1.5 minutes? Power is energy over time. energy, 100,000 divided by time, again in seconds, 1.5 times 60. So I get 1,111 watts. Okay, when we are doing a gravitational potential energy into kinetic energy question, we might be asked, what are we assuming in order to calculate the increase in kinetic energy as a stone falls through a distance of 5 meters? So, we are assuming that that gravitational potential energy all gets transferred into kinetic energy. But actually, that's not the case. And why is that? That is because some of the gravitational potential energy would be converted into heat. Why? Because we're assuming that there has been no work done by friction in these questions, so no energy being transferred into heat. But there would always be some kind of resistive or frictional force. For the stone here, it would be air resistance. So some of that gravitational potential energy will be dissipated to heat energy around the stone. This question for work done, explain why an object sliding across a surface eventually comes to a stop. So you need to talk about the fact that there is friction, okay, between the object and the surface, and that force of friction does work, and you could write the equation down, force times distance. And doing work means transferring energy. So the kinetic energy that the thing had is being transferred into thermal. Okay, and explain why rubbing your hands together generates heat. So again, you have friction. When you rub your hands together, that friction does work and transfers energy, kinetic energy of you moving your hands into thermal energy. Okay, some questions for power. 2 electric heaters are left running. They have power ratings of 3,000 and 2,000 watts. Explain which one generates more heat in 3 hours. First, we need to appreciate that heat is a type of energy. So I'm looking to relate these power ratings to energy. And I know that power is energy over time. So energy is power times time. Since these are both left on for 3 hours, the time's the same. So the one with the larger power does more heat in that time. So that is my 3,000 watt heater. Okay, one motor has a rating of 50 watts and another 60. Is it possible to tell from a power rating which motor is more efficient? What do we mean by efficient? First, from previous work, we might know that efficient means useful power over total power. 60 watts rather than 50 watts tells me that that 60 watt motor transfers more energy per second. So you might think, well, that one must be more efficient, but it's not just about the amount of energy it transfers per second, it's about how much useful energy it transfers per second. So it depends what percentage of that 60 watts is useful versus wasted energy, and the same for the 50 watts as well. So it's not possible to tell directly from a power rating which device is more efficient. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, tips and tricks for this section. So first one, any heat that gets transferred in any of these questions is due to work being done by some kind of frictional force, so by friction or air resistance. So sometimes they ask you that, just that is your stock answer for that question. Cars braking, yeah. In a situation where it talks about a car coming to rest, you are interested in the work that is being done by the brakes and the frictional force, setting that equal to the initial kinetic energy of that car. Okay, so just that should be a stock way of kind of answering one of those style questions. State questions. Sometimes for 1 mark, they will give a situation something like a stone or a rock, has an initial gravitational potential energy. State the kinetic energy of this rock when it hits the ground. If it's a state question, that's basically you have to assume all of that gravitational potential energy is transferred into kinetic. So you just read whatever that original gravitational potential energy is and write that as your kinetic energy. Okay, so the hint is there. The 1 mark means you shouldn't really have to do any calculations. You're just looking for a number somewhere in the question. GPE and work done. So this is more of a note. And here's this. Your work done is a force times a distance. When you are working out your GPE, the force that's acting on your object is gravity. So that is your weight, okay, which is m times g. So that's the force. And then the distance that it's fallen through is the height change, okay. So that mgh is equivalent to force times distance. That's just to give you a note that these that work is just energy transferred. Okay, so in the specific case where it is an object falling and that energy transfer is due to gravity, that's why you get this equivalence in these two equations. Okay, as always, mass in kilograms, time in seconds for these equations, and assumptions. If they say, what have you assumed when you're trying to calculate gravitational potential energy into kinetic energy, you assume that there's no air resistance or no friction, so that there is no work done and no energy transferred into thermal energy.